What if the secret breakthrough innovation isn't working harder, but thinking smarter about every step of the process? Welcome to Industry Ignited, the podcast where we sit down with trailblazers who are reshaping how industries think, build, and grow. I'm your host, Dr. Leeanne Aguilar, and today's guest is Anne-Marie O'Connell, a licensed professional engineer, MBA, and certified Six Sigma Black Belt, with more than 4 decades of experience driving process improvement, lean transformation, and product innovation. Anne-Marie, welcome to the show.
Thank you, Leanne. I'm happy to be here.
You've been leading MC Limited for nearly 5 decades, a remarkable run. What first drew you to engineering and process improvement?
The first part was my appreciation for science fiction, and my father's practical advice persuaded me to pursue engineering for my first BS degree. I originally wanted to become a physicist. I was accepted at what was then called General Motors Institute, where every student goes through multiple cross-functional co-op work assignments alongside of their schooling. At the end of the process, 4 years in, it's a 4.5 to 5 years degree program. You pick a thesis topic, and the combination of your co-op assignments in product design, product testing, manufacturing process development, and process improvement that showed me that I am especially good at process design and redesign. So during that fifth half year of earning a BS or BA degree at GMI, which is now called Kettering University, a student chooses or is assigned a topic related to their co-op sponsor's business. And then they research, develop one or more proposed solutions, present the solutions, and sell it to the people responsible in their organization for funding a change of this sort. And in many cases, the student goes ahead and implements the change they're recommending. Ideally, they're able to do that and collect data on the results of the change before the thesis is due. The student also reports progress during this time to a thesis advisor professor at school and the manager responsible for the project area if that person is not their workplace thesis advisor or their workplace supervisor, because they're generally also working as either an engineer or an analyst or in some fashion like that at that organization as well. And at the end of it all, when the thesis is accepted, it becomes part of GMI's library and is accessible to students or researchers for other things. That early kind of cross-functional exposure to all of the ways in which the details of a product's design and the details of a process's design interact with the product functionality, the cost of materials, the yield for a manufacturing process, and the service, the functionality will provide in service, drew me to get more involved in that interaction. So how product and process engineering collide, if it will, either for excellent success or explosive disassembly.
So tell me a little bit more about how these early experiences shaped your belief that process discipline can unlock creativity rather than stifle it.
I would actually claim that too much process discipline does indeed stifle creativity. A flexible and iterative design and development process with the discipline imposed primarily by physics or economics is ideal. You need a certain level of functionality for your product, and you need certain functions included in the feature set of this product. And it has to be made affordable. It has to be, and your organization may or may not have access to sufficient capital to automate it. There may or may not be technologies available to deliver this. All of those things, the discipline is provided by science and by physics, and economics, but the process itself is disciplined primarily by that physical relationship of what functions do I need, what features do I need to create those functions, to support those functions, and how much does it all cost?
Right. Yeah. I guess you have to be able to afford it in order to implement it. And
If an organization doesn't have the capital to get new tooling, or access to loans, access to more stock issuing, selling bonds, whatever. Um, if they can't get the money to tool up for this new product, they can't build the new product. If they can't get the money to finish development and testing, they can't build the new product. If the product turns out to be more expensive than the market thinks it's going to be worth, they won't sell the new product, and they'll never be able to repay the loans or pay your stockholders dividends, or or
Right.
any of the other, or keep paying people, or any of the other things they need to stay in business. So it has to be a balance.
Yeah.
And that is,
Yeah.
at one point, I was using a metaphor of like product process DNA.
Mm-hmm.
You have a set of functions that need to be provided for something to appeal to a particular customer or to perform a certain job. The design features, which are created by processing or engineering, or by how you put together a piece of software, the design features each have a cost and a certain minimum number of, and you also have alternative sets of features that you can use to provide the same functionality. Um, Ideally, what you do is you find the set of compatible features that gives you the function you need at the lowest possible cost. So you have to look at both feature and cost
Right.
get the product's design, its DNA, what it's going to be built out of.
Yeah. And then have some idea of the market as well, what they're willing to pay for it, what value they
Um,
can get out of
oh
it.
yes, I
And yeah.
mean the reason for controlling cost is to be able to meet or exceed the value you provide in the marketplace for your customers. You want them to think that the whether it's a $2 purchase or a $200,000 purchase, you want them to think that they got good value for their money, that it
Right.
does what they want, it does what they need, and it's going to be, useful or reliable or whatever for as long as they expect it to.
Right. So it meets their needs and their expectations.
Yes,
Yeah.
very much
So,
so.
so how did earning both your MBA and Six Sigma Black Belt expand your approach to solving technical and organizational challenges?
Um, well, I got my MBA initially because I had discovered while still a student that the people in charge of the capital budget of approving or not approving various projects pretty much control what an engineer can do in terms of implementing anything innovative or improvements of any sort. That's where the economics comes up against the engineering. So almost as soon as I had finished my bachelor's degree, I enrolled in an MBA program at the University of Michigan, and I finished that basically 5 years later. I had to take a year out for personal reasons in that. But it wasn't until 2000, and that was 1985. It wasn't until 2001 that I was introduced to the concept of Six Sigma black belts. Well, I had heard about it first from some colleagues who were very active in the design for manufacture and assembly forums at Motorola. And Motorola was one of the initiators of Six Sigma. But I started learning about and practicing some of the Six Sigma disciplines in 2001. So there was a 20-year gap in there
Yeah.
between well, yes, of course it has to pencil out before you can do this project, but um, and being able to run those break-even calculations and talk knowledgeably about, what discount rate should this be analyzed at? What is our internal cost of capital? And what does that mean for all of the things we need to do to keep our whole project portfolio, our product portfolio up to date, all of that kind of thing. Um, that can, and as far as I can tell, having studied several kinds of product and process improvement methodologies, the thing that is unique about Six Sigma is not so much the statistics, because anybody who's doing any kind of quality control or statistical quality control is Deming had that decades before Six Sigma came along.
Yeah.
But it is the insistence that the analysts and the teams that are going to work on improvement use the organization's internal financial metrics. They use whatever the finance operation in their employer that oversees the project uses. That does make it easier to convince those financial people to fund or not fund various projects. You can skip a couple steps in building your own credibility if you're
Yeah.
using their numbers
Right. So it's
in
that
their format.
transparency, like the
Yes.
transparency just allow, and that makes sense. So I mean, you're basing it on numbers. I mean, actual hard data.
Well, yeah. Well, you're basing the finances on the financial organization's numbers, values, and norms. You can argue quite a lot about how indirect costs might be assigned to various operations and various things, but that's kind of the intersection of industrial engineering and time study and sort of work with the finance people. At the end of the day, the finance people control the money in an organization to a very large degree. So
Right.
you use their numbers, you use their language to explain things, and you're more likely to get your project approved. Or at least you'll understand why they picked, these other three projects instead of the ones.
Right. Okay. So it helps with that communications, making
It
sure
does.
you're speaking the same language, you're all on the same page, looking at the same
And
information. Yeah.
looking at the same information, and hopefully you reach a consensus of what is the best thing to do for this part of the organization and the organization as a whole.
Yeah. And now you've worked through or across a lot of industries, from metal
Hmm.
cutting to electronics to high volume assembly. What lessons have proven universal no matter the field?
Person or the team that is seeking to make improvements needs to observe the process as is. You need a reasonable baseline, and um, knowledgeable observation is one thing, but you also need to ask questions about, inquire as to what is troublesome or easy or hard for the people who are embedded in the process as is. And that is often a source of insight as to what might be going wrong in a process, or what needs to be improved in some way for the process so that it becomes more reliable or more consistent output, or just um, doesn't make people sick or injure them.
Right. No, that's important. Right. Yeah.
And it,
Yeah.
it does
Safety.
sometimes happen in industrial processes that the way we have always done it worked fine when the only people who were being hired into factories were young men. But if you have a more diverse workforce, or you suddenly have more limitations on the workforce you can get, you might have to redesign your processes to work with the people you have
Hmm.
or can get. If you're looking to automate a process, you have to be very sure that the automation technology actually can handle all the functions that the current system is using. Or you have to reallocate those functions and find another automation for the things that your robot, for example, can't do.
So making sure that technology is in line with the process and the outcomes that are needed.
with all of the outcomes, because if part of the job is that the person um, has to put layers of cardboard in between parts that they're loading in or out of a shipping container, or of a container that's going to the next plant, or it's at the end of the production line and they're being shipped to where your module will be incorporated with other modules. You have to have a robot that, if you want to robotize that, you have to have a robot that can also put the cardboard in place.
Hmm. Right.
Um, Sheets of cardboard aren't too hard for robots, but closing a box is like actually most effectively done with three robots, not one. You got to go flaps in, tape on if you're
Right.
closing a box.
Yeah.
Easy for people, much more complicated to automate,
Yeah.
because it uses flexible material, and that flexible
Right.
material is much harder.
Yeah.
And as a matter of fact, sewing pieces of flexible material together, sewing or heat welding or sonic welding flexible materials together, is almost not automatable at this point. That we're just beginning to get humanoid robots who can do something like that,
because of
because
the
it requires
flexible, yeah,
coordination of
yeah,
multiple fingers, two hands, at least two grips, and placement of things that are flexible.
yeah. So I'm hearing that it's really important to be maintaining curiosity, really asking the right questions, understanding what's all involved in the process. And not only that, but understanding the outcomes that you're needing and
Mm-hmm,
putting the technology in place that's suitable or that can actually accomplish those tasks. If you're looking at automated technology, that
mm-hmm.
it's actually capable of producing the outcomes that you're needing. So understanding the limitations of the technology as well.
The other thing that people have been trying to do more is to do virtual product development and virtual process development, in which case you need to like operate on models of both your as is. You want to model both the as is process in this virtual tool and the process in order to kind of validate your modeling of that, and you want to be able to reproduce in your as is model. You want to be able to backcast,
Hmm.
as I'd say, that if I start from these known conditions, I can produce these known outcomes and essentially duplicate what happened during a specific shift, a previously recorded shift or a previously recorded product,
Right.
product
Yeah.
test
Yeah. So,
with your new one.
right. Yeah. Comparing, I guess, running the simulations with the current models versus the new models to really
Hmm.
understand where you're at and what may have happened, that was not successful in a process versus the new alternative
Yes.
process. Yeah. A lot of leaders talk about continuous improvement, but few sustain it. What separates organizations that talk lean from those that actually live lean?
I'm gonna have to disappoint you on that. I can't honestly say I've ever worked or consulted for an organization where the commitment to Lean or Six Sigma or DFM, DFA or value engineering, value analysis, or any other product and process development or product and process improvement program lasted for more than a couple of years. That might be because no single one of those products completely supports the entire product life cycle, because any one of them may be necessary to get the results you want. Six Sigma, for example. Six Sigma is necessary but not sufficient to run an organization lean. The lean methodology is perhaps necessary but not sufficient. You have to have some way of training, of systematizing maintenance, systematizing quality checks, systematizing a continuous improvement, or at least a maintenance of a high level of performance for your processes. But that is not enough to make a successful product, because if you're making the wrong product for the market, or even if you are making it completely to specifications,
Yeah.
something happens and all of a sudden someone else has innovated and theirs is cheaper but just as good, you're going to lose market share. And you have to find a way to make it cheaper, because the idea behind lean is mostly to get to a good point in the process and make sure it stays there instead of continuously improving in any major way, because the
So it's more
equipment wears out.
right, right.
The
So it's more
equipment
about
wears out, the,
sustainability.
the
Yeah.
materials get more expensive, there's a trade shock, somebody imposed tariffs on something, and the volume changes. And all of a
Yeah.
sudden, your process is not efficient at those volumes.
Right. So it's a good ideology. It's a good starting point, but it's
Hmm.
not enough to really run a process all the way through or run a business so it's
It,
sustainable.
it's not a sustainable way to run a business, um, without periodic disruptions anyway. I
Right.
have I have been given to understand that Toyota has sustained a long-lasting commitment to what they call lean, along with a discipline called quality function deployment, which is some of where the we have a function and are instantiating that function by means of a set of features. That's related and derived from quality function deployment work. But I haven't ever been in the room where it happens.
Mm, yeah. And he said,
So maybe Toyota is, but I
yeah,
don't know how they've done it.
yeah. Huh, interesting. Right, because there are so many variables. There are so many things
There are a
that
lot of
kind of
them.
come up and disrupt the system and the process. And um, well, then how do you balance the quantitative rigor of Six Sigma with the human side of change, getting teams to buy in and stay motivated?
Well, for the most part, uh, black belt or master black belt can partially insulate many of the team members from the quantitative rigor. You don't have to make everybody on the team a statistician. But it does help if everybody on the team, and if at all possible, their boss understands what data you're collecting, why the team is collecting those data, and once you start planning for implementation, how confident are you that the analysis of the data is going to actually produce um, the forecast improvement in one thing or another? But yeah, the other thing that helps is to um, be very upfront about acknowledging the very natural resistance people have to change, saying, I am going to ask you to do something that is difficult.
Right.
And here's why. Here's why it's important. Yes, it is difficult. Here's the kind of support that we usually give. Is any of this useful to you in reconciling you to the fact that we'll all have to change and it will be uncomfortable for a while?
Mm-hmm.
Um, that often does help.
Right.
It doesn't always help. And yes, the change management is the single most challenging part of a Six Sigma skill set, being able to persuade people to at least give it a try and
Mm-hmm.
reassuring them that just because it's uncomfortable after the first few hours or the first few days, that they should not give up.
Right.
So you have to be pretty relentless on your follow-up.
Yeah. So probably
And
explaining like why, getting them to buy into the why,
mhm,
and really communicating beforehand, what's happening, providing some transparency around the whole objective,
mhm.
perhaps. Yeah.
And um, for in a very large measure, the employees' buy-in will be contingent on their bosses' buy-in as well.
Mm-hmm.
If their boss is bought into it, we really need what the change is supposed to give us, and is patient enough to keep encouraging people to, yes, keep doing it the new way, keep doing it the new way, keep doing it the new way. Um, Eventually everybody will be doing it the new way.
Yeah.
If the bosses are also resistant, you may not get a successful change. You won't get the change rolled out well or consistently or as fast as you might hope.
Yeah. So focusing on getting the buy-in from the leaders initially
Hmm.
will then influence the buy-in from the team and keeping the team motivated.
And in all too many cases, the team who comes up with the suggestion is not um, real directly connected to the people who will have to change their process.
Mm-hmm. Who implement it. Interesting.
Ideally, it would be, but that doesn't always happen.
Yeah. And why is that?
Roles and responsibilities kind of thing. We tend to get the engineers and the designers and the finance analysts assigned to improvement teams, not the shop floor workers. And and even if you can get them in for some of the mind setting and problem problem discussion and framing and the brainstorming, um, we're not going to get them to sit through all of the discussions of trade-offs and so forth and so on, nor should we force them to. But
Right.
having a fully cross-functional team with at least some of the people who are going to have to be directly involved in or affected by the implementation means you don't make some bad misses where you, oh, that's great, except what about,
Yeah.
that's great, except what do we do about the power out, about the power flickers? Somebody, at least once I was working on a project involving a laser welding process um, that was very inconsistent. And it turns out that the reason the laser welding process was very inconsistent was the power quality of the electric power provided to that plant.
Oh.
And one of the major sources of power disruptions in both frequency and voltage turned out to be earthquakes, which there was not a thing that
Yeah.
we were going to do about earthquakes.
Right. Right.
But we could essentially get a power quality improvement device, which is a kind of an especially set up in power inverter
Mm-hmm.
to give that laser welder really nice square waves at a very fixed frequency, no matter what the mains power was doing for the plant.
Right.
Lights will
Yeah.
flicker, laser will not.
Yeah. Right. Okay. So it really.
But I mean, that took a very deep dive into what was going on, and that
Mm-hmm.
took someone who really understood laser welding to figure that part out.
Yeah. No, that is not intuitive, not something at surface level that you would, find. I
Um,
mean, right.
that,
You'd
right. It was not a thing exactly.
right. So root
Another,
cause analysis is like
you have
super
to get to
important
the,
in the
the
process.
actual real root.
Yeah.
That was the third pass on trying to make that particular operation more consistent.
Hmm.
Was when I finally got involved at that one. Another one was where a process had been designed to induction harden a clutch component. Okay, you have a clutch with little lugs on the outside that the parking pawl engages, and that had to be really tough and to support emergency parking and emergency brake and sort of thing interactions. But the inductive hardening process generated so much electromagnetic noise that it interfered with the nearby um, airport control tower.
You're kidding.
I am not.
Wow.
It was a second tier airport primarily used for cargo flights
Yeah.
and general aviation, but there was a frantic 2 weeks of shutting that down to build Faraday cages around the machines
Uh-huh.
so that we did not transmit
Interfere
all
with
that
the,
noise
yeah,
out of the plant.
with the flights.
And
Yeah.
that had been completely kind of invisible to the people who were designing that process because the electromagnetic noise was not a thing that they had ever thought they
Hmm.
needed to worry about in a factory.
Right. Right.
Well, we didn't if we could keep the noise in the factory, which is why we had Faraday cages built
Yeah.
around the machines. Um, but it was particularly troublesome when the FCC comes calling saying, we have been tracing this from over there at the airport. We have been bringing our directional signal finders and we are here at your door. And what the hell did you do?
Right. Right. What is going on here?
Why are you making so much noise in this spectrum where you shouldn't be broadcasting at all?
At all. Yeah. Without even realizing it. Yeah.
Yeah.
In your experience, where do most improvement initiatives fail, and how can leaders avoid falling into those traps?
Mm. I would say that the improvement initiatives that fail are the ones that are perhaps too narrowly focused on either um, cost reduction or product improvement, or um, what we need is to reduce direct labor or reduce material cost or reduce the ones that are most narrowly focused are the ones most prone to not meet their goals. The ones that say we want to look at this product or this process in its environment and look for ways where we can make gains of, of functionality, reductions in cost for the whole interconnected system that it's embedded in. The other ones are where everybody, including the project sponsors and the people who are facilitating the process of improvement, don't acknowledge that change is hard. Don't acknowledge that um, there are potentially conflicting goals between the group on the shop floor, the group in engineering, the people in purchasing, and our downstream customer.
Mm-hmm.
So if you can't be honest about all of those things, if you have to pretend that those conflicts don't exist, your chances of the initiative failing are much higher.
Right. Yeah. So right, before implementing the change initiative, I guess really analyzing where the conflicts are and making
Oh,
sure
yes.
that you're addressing those first, or as part of the initiative.
Hmm.
Yeah, or else it'll get stuck, and there'll be friction. Is what I'm hearing. Yeah.
Yeah.
You specialize in design for manufacture and assembly. What one
Hmm.
example where redesigning for manufacturability radically improved both cost and quality?
I was not the facilitator for this particular one, but it was in cooperation with an initiative at an automaker. One of our suppliers did a redesign effort for product simplification and cost reduction and managed to um, change the design of a clutch return spring to be, instead of being a subassembly with 16 individual parts, to turn it into one wave spring, which reduced the weight slightly, got the same functionality, and significantly reduced cost. So, as well as part count. And it also improved serviceability
Mm-hmm.
because when it was an assembly of a stamped piece with attached helical springs, there are different spring forces that were supposed to go in for this and not. And the service pack for this had a clutch and 3 bags of springs of the 3 most common spring forces needed to get the right amount of travel under load, under a specified load. So instead of a clutch and 3 bags of springs, they got 3 different possible wave springs. It made it made the whole thing potentially more compact for the
Yeah.
next time they were redesigning the entire automatic transmission
Yeah.
as well with that application. So it was lower cost, lower part count, easier service, and just win-win-win for practically everything,
Right.
except the people who make helical springs.
Right. Yeah, they weren't too happy about that.
They were not thrilled, but
But that's
um,
innovation. It happens. You want to get more efficient. You want to get more cost effective and
and there are
improve
plenty
quality.
of places where we need lots and lots of helical springs too. So
Yeah, yeah. So they're still in business. Now you've facilitated countless cross-functional teams. What are your favorite techniques for drawing out ideas from people who don't usually speak up?
well, if it's a general reluctance to talk, which sometimes does happen, especially on the first meeting of a team or the first day of a workshop, if you're doing this as an intensive, off to the side effort. One of the easiest ways is to go around the table, one after another, every time that you're looking for input or a comment, kind of a thing, and asking everybody to speak up with something, hopefully at least somewhat relevant, and say, okay, for this part of the exercise, you get to pass only 3 times. Other than that, you have to say something that is germane to this topic. And then almost everybody does contribute, and it tends to break the ice. If
Yeah.
you just have 1 or 2 people who are never talking, you can use something like a Nerf ball or a pom pom, a yarn puff to toss from person to person to invite the next person to contribute when you're doing a round robin and trying to surface ideas or surface comments. And if somebody is just not talking and really not talking and kind of leaning way back so they can't catch the ball or get handed the thing you're using, I will kind of signal that I want the ball, and I say, come on, we need everybody to play, and
Yeah, just
toss
kind of
it
calling him
to
out a little
them,
bit.
call them out a little
Yeah,
bit.
yeah.
Um, but another way to kind of get more participation in that is a technique called 5 why, where you repeatedly ask, and why do we do that? Why do we do X? We do X to get Y. Why do we do Y?
Yeah.
And we want Y because the customers want Y. What is it customers want that Y does for them? Why do they
So just
want that?
digging deeper,
And
just keep
then
digging.
and
Yeah.
why do they want that? And you dig down and down and down as far as you need to until it makes sense. But generally you want to ask why at least 5 times to get to the real root of what is desirable about about a change or a product
Yeah.
feature, or what is undesirable or difficult or problematic about a change or about the current design. So, why do we have gear teeth? Well, we have gear teeth in order to transmit power in mechanical power and rotation. Why do we need to transmit mechanical power? In this instance, it's because we want to turn the wheels on the car.
Yeah.
Or why rotation? Well, because the wheels need to turn in order to make the car go,
Yeah.
So framing those whys can get people more involved in trying to come up with, better explanations for why would we do this? Why are we spinning this drill? We're spinning this drill to make a hole. Why do we need the hole? We need the hole for the oil to go through for X or Y. And why do we
Yeah.
need the oil?
Right. So it's really connecting the processes with the outcomes in that
Exactly.
case, helping them get buy-in and motivating them by seeing the overall purpose of how they're contributing and how the process is contributing to the overall outcome. Yeah.
Exactly.
Yeah. And I think, yeah, gamification is great in a lot of regards in getting people to open up, to participate, to
mhm.
relax a little bit if there's fun involved. Right.
And that's a related interest of mine. My family is very involved in a number of different tabletop role playing games.
Mm-hmm.
And that kind of gamification is a great way to teach people about a system or to teach people about things with complex and interlocking pieces. And a friend of mine who's a professor of education was teaching a class on gamification as a way of teaching content. And so I and some friends designed a game simulation for her students to go through so that they could see what it felt like, that specifically reinforced some of the things that she was trying to teach them about how to make an engaging lesson plan or how to make an engaging activity for
Right.
students,
Yeah.
starting with your learning objectives and ending with a couple of scripts and some props for people to run
Right.
around the classroom.
Yeah. I mean, people are competitive by nature. And if
um,
create goals and objectives and something to accomplish, then it
mhm.
motivates, I think, intrinsically.
And so I have a T-shirt that says Do not kill, maim, or rob. I am an essential non-player character. The goal of the game will be lost. You know,
Yeah, yeah. Like you
my
lose if
survival is essential to your winning the game.
right, right. Yeah. No, I mean in a
And I wore that T-shirt to be the game master, setting it all up when I did it for her, because she had said, "What's an NPC?" to me, and I said, "Oh, non-player character,
yeah.
the cat who gives you a side quest and
Right.
the information you're going to need to know to get into the cave of treasures when you get there."
Yeah.
That kind of thing. That's a non-player character. And yes, gamification is a good way of keeping people somewhat interested anyway in doing their jobs,
Right,
or
right.
doing an aspect of how could my job be different in a way that makes it better.
Mhm. Yeah, because when you start talking about Lean and Six Sigma, I mean, these are often seen as like technical disciplines, and but on the other hand, culture plays a huge role in the success of a company. How do you
Mhm.
help leaders make process excellence part of their organization's DNA?
Ooh. Generally, I would try to connect each workers or each leader's own desire for or motivation towards excellence as they define it, and connect that with product excellence, process excellence, the discipline of doing the work all the time kind of a thing. What does being innovative mean to you, and how would that leader define excellence in innovation or excellence in maintaining a quality system so that all the checks that are supposed to be done are done, the gauges are calibrated appropriately, the process is maintained and clearly communicated, data is collected and reported and analyzed. And if suddenly the quality analyst for this plant is expecting to get reports from operation 14 every shift, and all of a sudden second shift isn't doing it, they don't it doesn't take them 3 months to notice and go
Yeah.
investigate that the person comes back and says, "Hey, I didn't get your records on when you did the gauging for this. But there's how do we know that this is still in control?" Or that people actually do pay attention to automated systems that do automatic and in-station gauging, that it's not just the computer is flashing lights to itself.
Hmm. But
About
understanding
a
what's
green, yellow,
happening.
red,
Yeah.
measurement on this particular quality check. Does the operator know what that red light means? Do they know what the yellow light means?
Yeah. Yeah, right. I know. Yeah, so I guess it comes down to communicating, to training,
Communicating,
training.
training,
Uh-huh.
and to, like, most people want to do a good job if you don't make it too hard for them, or
Right. Yeah.
too difficult, too boring, too strenuous, whatever. So you have to, like, fit the worker to the job and the job to the worker, or to the population of workers you're most likely to have. And the workers we have for top management and the people who will sustain effort to improve things, they want to think of themselves as smart and innovative and responsible people. This is
Yeah.
one of the ways you can be a smart and innovative person, is to follow this process and to applaud your workers and to follow up and make sure that they're always doing their part.
So set them up for success. So set your team up for success, making
Hmm.
sure that they understand how the process works, equip them with the tools and the information, the resources for
Hmm.
doing a good job, and then following up with them regularly to make sure that they're
Yeah.
happy and on the same page. And yeah.
And like the lean tours, where you go and walk around a process to just look at something where a problem has been reported, or you just haven't looked at it for a while. Having everybody do this, let's go out and look what happened, what
Right.
has been happening. Um, do we need to make a change do we need to make a formal change, or do we need to retrain somebody, or do we just
Right. Yeah. So going in, including the important parties in that discovery and problem solving, and then once you've identified where the failure was, putting something
Mhm.
into place to educate and make sure it doesn't happen again is what I'm
Right.
hearing.
The idea is to minimize the chances that people will make the same mistake twice,
Yeah, exactly.
or
Right.
organizations make the same mistake twice.
Yeah, using everything as a learning tool. Yeah.
And well, that attitude that every mistake is an opportunity to improve for the next time means you have to be not punitive about mistakes,
Yeah.
at least not punitive about genuine mistakes. I mean, there are people who will sabotage things.
Right. If it's neglect or if it's sabotage, that's a different story.
Yes,
Exactly. Yeah.
but if someone knows why you are asking them to do X every 2 hours, to make this check, to make that, whatever, and it's easier for them. It's often easier for them to actually be reliable about doing
Right. Yeah.
it.
Now, you've trained and mentored many engineers and program managers. What
Mhm.
advice do you give the next generation of leaders about influencing without authority?
I have had great success by treating everyone the way I treat volunteers in volunteer organizations who are working for or on or with a particular project. People expect to get paid for their work, and they should be paid for their work, and they should be paid fairly for their work. But money is not the only motivator. And so respect, opportunities to improve or to learn new things or to try new things are important, all of that. So I actually got my first job as a skilled trades supervisor because I was a community theater volunteer who had worked for a person who the superintendent of the plant also worked with. Because he asked me, well, these guys are all older than you and you don't actually have a skilled trade certification. How would you handle that? And I said, I would treat them the way I treat the people at the theater where I work and have been a producer and props manager and designer and builder. I would respect their competence in their areas and say, my part of the job is helping manage priorities and making sure you have the information and the tools you need to do your job well. And he says, you've worked in community theater. Have you ever worked with me for like this particular person? And I said, twice now I have been her stage manager as a director. And she said, if she let you work for her twice, you
Yeah.
are good enough to work for me.
Right. You never know where you'll get opportunities. Yeah, that's true.
And I actually did have very, very little trouble in that job, aside from one person. And the problem I had with him was not actually a problem that had anything to do with me. It was that my voice was almost exactly the same as his ex-wife.
No.
So I had to like develop some workarounds and almost never give him direct instructions. And because in particularly in the construction and installation phase we were in, almost all of those of people were working in teams of two for safety reasons. I could address my remarks to his partner and not directly to him, and never say anything the least bit unpleasant or directive to him. I could say,
So you don't
you
trigger
want a
his,
donut?
yeah.
You want a donut?
Right.
That was fine. You want one of these cupcakes? Yeah, that's okay. But telling him what to do
Would
made him
trigger
see
that,
red
right?
and
Yeah,
would trigger
exactly.
great resistance.
Yeah, great
So I would
resistance.
say to his partner, I'd like you guys to do X. And here's the prints, here's the thing, here's the special, here's these parts that need to be added, and let me know what else once you've had a chance to look at the job. And if you could give me an estimate of about when you think you'd be finished once you've had a look at it. And without ever addressing him directly, that worked. but it took a couple months before we
Right.
got
No, that was creative.
before
That
it
was
got that good.
intuitive. Yeah, intuitive to figure that that out,
That
what was
it
triggering him.
it
But
took
you
a
are
bit of
working with
gossip from
people.
one of the other tradespeople to
Ah,
say,
okay.
"No, no, it's not you. It he doesn't hate you. It's just that you sound just like his ex-wife."
Oh, wow.
Oh, okay. I can
We can work with that. We can,
I
yeah.
can work with that. I
At least you know, the information is crucial, right?
Oh, yeah.
Mhm. Yeah. So continuous improvement can sometimes feel like never enough. How do you know when a process is truly optimized or when it's time to innovate again?
Well, any process will only stay optimized for a relatively short time because the operator or some aspect of the design, the production volume, or the equipment will change. So, in the face of change, you probably have a backlog of things to look at. Figuring out a period after which you should always look might be tied to some aspects of your quality system where you have to do capability studies, or you have to do this, or you have to do that. Or when you are about to launch a new product, you look at the things that you're going to carry over from the old one and say, wow, we're making these other changes. What should we change about this? Uh, I I'm not sure there is one right way for all organizations to do that.
Yeah.
But having at very least a thoughtful discussion among the people who are in charge of innovation or quality and just maintenance of processes is probably the right thing for every organization to do. Yeah.
Things do change. Like you said, there are a lot of moving parts, a lot of so
Oh,
while something is optimized for a while, it's not necessarily going to stay that way, especially with AI now. And there's so many changes in how we design and manufacture. So how do you see process engineering evolving into the next decade?
well, we are seeing more applications of digital twins for both products and for equipment used in producing products. And as that technology becomes more widespread and easier to use, we will see less expensive exploration of a wider variety of options for pretty much every product and process. Um, they would allow, you can study in detail the assembly process, the disassembly process, the operations of almost any physical product, and using a digital twin kind of an environment. Right now, the 3D digitization process is the gating item. It is time consuming to do it with sufficient accuracy to be able to base predictions on it, to be able to produce new designs on that. And it will take closer and widespread collaboration between the people who are making things and the people who are designing things to get that digital twin process, the process of creating digital twins, accurate enough and cheap enough to make them useful. Because right now they're talking at a very high level of abstraction for the most
Hmm.
part, but we've had a wave of things called uh, product data management or product lifecycle management databases that contain CAD files and test results and this and that and the other. But the learning curve for implementing one in a company, and especially for teaching all of your engineers, designers, quality specialists, and finance people to use that, the learning curve is very steep for all of those systems. And I'm thinking that digital twins will have to progress to the point where their learning curve and their development time is at least as good as the product data managers and product lifecycle data systems have become in the last 10 years. There's a great deal of promise, but right now it is significantly more work
Right.
to implement digital twinning than
Yeah.
it is to implement a traditional design cycle,
Right, because
whatever
of the
that is
learning
in the
curve
industry
and
in
yeah, the
question.
costs and the time and yeah, the investment, just that whole learning curve.
Yes.
So, yeah. So what new skill sets will tomorrow's engineers and process leaders need to stay relevant in this changing landscape?
I'm going to challenge that assumption a little bit. I think one of the most important skills going forward, especially as we get more virtual in our manipulation of designs and processes, will be estimation. Doing a sanity check. Is this the right order of magnitude? Given what I know about the underlying physics and the underlying economics of the situation, because you need to check both the math and the physics of a proposal before on any kind of an idea, whether it's unless it's only ever going to be all virtual. Then
Right.
all you need to do is check the math. How fast does this generate data? How fast does this generate data? How long do we have to save the data for? And how much is it going to cost to have that accessible to all the users? That's the only math if something is only ever in a virtual realm.
Yeah.
But if you're going to create physical products of any kind, you need to check the physics, you need to check the math, at very least to rough orders of magnitude, very early in the process of evaluating
Yeah.
a possible innovation.
Yeah. Well, and I guess so they need to understand how to do that then. They'll need an overall
Oh,
awareness of what's involved in checking the physics and the math, you know.
yes, yes.
Yeah.
And that's why I say that's an old school skill to be able to look at something and say, what are the underlying equations that control the relationship of X to Y? What is the in the Six Sigma kind of world? What is the function that relates X to Y? I
Hmm.
have these X's. I want these Y's. What's the function that connects them?
Yeah.
Knowing that about the physics, about the economics, about the math of whatever process and whatever product, that's going to be a critical skill to be able to
Yeah.
reasonably use all these great new virtual tools.
Yeah. No, that makes sense. Yeah, really understanding what connects everything and then um, where the virtual tools have their place, how they fit
Hmm.
in to that equation. Yeah. So
Yes.
finally, Anne Marie, after decades of helping organizations achieve measurable results, what still excites you most about the work that you do?
Um, I would say that the most exciting part of this work is the creativity and enthusiasm of the team members in organizations where their collaboration and the continuous improvement is well supported. It's not seen as your punishment for suggesting this idea is that you have to you have to sit through this 3-day workshop, or you have to write this report every month about how we're coming on getting it done with no budget and no kind of organizational political support for this effort. But lots of people, especially engineering type people, but lots of people enjoy learning about the how and the why of what they are doing and how that affects um, what the product does or what the service does for the customers, how that affects the whole organization, how that affects the profitability of the organization, and how it affects the people they know who are customers
Yeah.
for that organization.
Yeah. Well, Anne Marie, thank you. Yeah, it's been a wonderful conversation. Thank you for sharing your wisdom and experience on both the science and the art of process improvement. For listeners who want to learn more about your work or connect with you, what's the best way they can reach you?
Well, I will say my email address is amoc@comcast.net, or through LinkedIn if they happen to be on there. I am Anne Marie O'Connell, PE, MBA, Six Sigma Black Belt. So, and I'm one of maybe a couple hundred O'Connells that
Uh-huh.
I have found.
That are Anne Marie as well? Anne Marie
um,
O'Connell or just
there
O'Connell?
is at least one Anne with an E, Marie O'Connell in Ireland,
Okay. Oh,
but
okay. All right. So Anne with
but
no E.
Anne
Yeah.
with no E is I believe unique.
Yeah. Okay. Well, and to our audience, be sure to follow and subscribe so you don't miss upcoming episodes with the innovators redefining how industry works. Until next time, stay bold, stay curious, and keep igniting industry.